Okay, so let's go ahead and do our residential foundation exercise. So first thing we're going to do is we're going to calculate our line length. So our center line length is what we're after. And the nice thing, of course, about the center line length is that's one number that gives us the entire length of the wall and the same number we use for the footing. So, of course, like we talked about before, when we're dealing with a foundation that has jogs in it, if those jogs are only two-sided jogs, like these two-sided jogs, we can treat this as if it's one simple square, okay? So when we're calculating our center line length, we want to take the width and the length of our foundation, make some adjustments to those numbers, and then we'll multiply those by 2 to include the other 2 walls that are missing. So when we're calculating center line, we want to go from the full width of our building, which is outside of wall to outside of wall. In order to get to the center of the wall and the center of the wall, we have to subtract a half a wall thickness at either end. So from an outside to outside measurement, if we simply subtract one wall thickness, that will give us the center line length for the width of our building. So we have 10.4 meters minus 0.2 will give us 10.2 meters will be the center line length of that wall. Now we can take the length of our building here, which is 15.6 meters. That's from outside to outside of wall. If we subtract a half a wall at each end here, that will get us a center line or center of wall to center of wall measurement. So 15.6 becomes 15.4. So now that we have our width and our length, we can take the 10.2, add it to the 15.4. We'll multiply that now by 2 to include the other sides. So times 2, which gives us our center line length now of 51.2. So now that we have our center line length, we can go ahead and easily calculate the volume for our footing and for our walls. So with this length, we now multiply that by the 2 dimensions for our footing. We have a width of 0.4 meters, which is 400 mils, and then multiply that by the depth of our footing, which is a 0.25. The volume now for our footings is 5.12 cubic meters. So let's go ahead and take our center line length of 51.2 and multiply that now by the 2 dimensions that we're missing for our foundation wall, which is times a 0.2 in thickness and then multiply by a 1.2 meters in height, which gives us a volume for our foundation walls of 12.288 cubic meters. And now we have to work through our slab dimensions. Okay, so we're going to go ahead and draw 2 squares here, which are going to represent the 2 jogs in our floor. And we have to start by calculating the larger square of our entire basement, including our jogs. So we want to get the full width and the full length of the inside of our basement slab. So we have to take the width of our building from outside of wall to outside of wall and get a dimension inside of wall to calculate our slab area. So we take a 10.4 minus a wall thickness here and minus a wall thickness on this end, which would be 0.4, and that will give us a 10 meter width for our slab. Now we'll multiply that by the length of our building from inside of foundation wall to inside of foundation wall. That will be 15.6 minus 2 wall thicknesses, which will give us 15.2. So let's go ahead and get the area now for just this greater slab square. So 10 times 15.2 should be 152 square meters. So there's our starting area. Now what we have to do is calculate the area that we're going to subtract from that for the 2 jogs. Now, on the outside of our building, those are the measurements for our jogs. We have a 4.5 by 5.6 jog. The size of that jog on the outside of the wall is identical to the jog on the inside of the wall. So we can simply take our two jog dimensions, multiply them to get that area. So we have a 5.6 times a 4.5. So the green square that we will subtract is a 25.2. And then the orange area is a 3.1 multiplied by 4.5 is 13.95. So let's go ahead and subtract both of these numbers from the greater square, and that will give us the area of our basement slab. So we start with the 152. Let's subtract 25.2 and subtract 13.95. Now we have an accurate basement slab measurement of 112.85 square meters. Now all we have to do, once we have a usable square meters, is simply multiply that by the thickness of the slab, which is multiplied by 0.1 or 100 millimeters. Gives us now a volume for a basement slab of 11.285 cubic meters. Now we can go ahead and add all this together for our total concrete. So we'll add to that the wall volume, which is 12.288. We'll add to that the 5.12, which gives us a total concrete of 28.693 cubic meters. Okay, easy enough, right? Of course. So now we're going to go ahead into our form panel. So I'm just simply going to get a new sheet, and we'll start going through our form panel calculations. Oops. Okay, so our form panels, we have our outside and inside corners. So let's go ahead and just draw at least one corner set on that. Now the outside and inside corner panels line up perfectly. So the dimension of our form panels are 600 millimeters. That's the size of an outside corner form and a regular form. Now the inside form panel, the inside corner, is the outside measurement, which is 600 mils, minus the thickness of the wall, will give us the size of our inside panel. So an out corner is 600, an in corner is 600 minus the wall thickness.
Can I ask you a question, Bob?
Is 400. Yeah, go ahead.
When it comes to, well, because I know that sometimes like the form panels, they're going to be a little bit bigger, right? Or is it always going to be 600 mils?
600 mils, if they are bigger, then you have to calculate everything slightly differently.
Well, I guess like the actual thickness of it is determined by like the figure on the right side where it's 200, right? Or is that something?
That's correct. The inside corner, inside form corner is calculated always by the outside form panel size minus the thickness of the wall.
Okay. So like, could you have something that's like 300 and then so that would change the actual number of the form panel? It'd be like 800 or something, or something maybe a little bigger than 600? You know what I mean?
No, I mean, you mean starting with the measurement of the inside?
No, I mean like well, because like sometimes your form panel is going to be bigger. So like, would that be, let's say if your thickness is like 300, would that make it bigger?
Let's do this. It doesn't matter what the size of the outside form panel is. Whatever it is, you minus the wall thickness, and that will be the size of the inside.
Okay, yeah.
Yeah, it doesn't matter what size it is. That'll always be the case. So we have a 400 inside corner panel size dimension, 600 outside. So now we have those adjustments that we're going to make, because what we're really looking for here is we have to find the length of every wall in between our corner panel sets, because this is the portion of the wall that regular form panels are up against. So we have adjustments to make. If it's an outside to outside corner like this, we will minus one outside corner panel here of 600 and one outside corner panel here of 600. That will give us the in-between corner panel dimension. So 0.6 and 0.6 is a minus 1.2. If it's an outside corner to an inside corner, an out to in, we will minus a 600 for the out and a 400 for the in, which is simply minus 1 meter even. Okay, so we're going to go ahead and do our measurement and form panel counts in one shot. And keep it in mind that whatever the count is we calculate for the outside, we double it, and that'll be the count for the inside as well. So let's go ahead and take our long wall of 15.6 meters. It's an outside to outside corner, so we'll make the adjustment of minus 1.2. Now we have the in-between corner panel size or distance of 14.4 meters. We'll divide that by 0.6, which is the size of a form panel, which leaves us with 24 panels even, no fillers. Now we'll go ahead and we'll do the jogs. We'll do everything that we actually have numbers for first. So this part of the jog here is 5.6. We have an outside to inside corner, so we minus 1 meter, which leaves us with an in-between corner panel dimension of 4.6 meters. We'll divide that by 0.6, the panel size, which leaves us with a 7.666 panels, or 7 full panels plus 1 filler. We have a 4.5 meter wall here. It's an outside to inside corner, which means we minus 1 meter, which leaves us with a 3.5 in between corner panel measurement. Divide that by the size of the panel, 5.83, or 5 full panels plus 1 filler. That'll be the same for this jog that's 4.5 meters. It'll be 5 panels plus 1 filler. Let's go ahead now and we'll do this jog, which is 3.1. Inside to outside corner, we minus 1, which leaves a 2.1 distance. Divide that by the corner panel size of 0.6 is 3.5 panels, or 3 full panels plus 1 filler. Now, both of these ends are the same measurement, so let's go ahead and calculate one. We start with an outside to outside of 10.4. We'll minus a 4.5 for the jog, which leaves us with an outside to outside corner of 5.9. We will minus our outside to outside corner adjustment of 1.2, which leaves us with a 4.7 in between corner panel sets. We'll divide that by the size of our panel, 0.6, which leaves us with 7.8 panels, or 7 full panels plus 1 filler. This side will be the same, 7 panels plus 1 filler. Now all we have left is this section here. So we'll take our full length first, which is 15.6. We will subtract 3.1 and then subtract 5.6, which leaves us with an outside to outside corner measurement of 6.9. We will make our outside to outside adjustment for our corner panels, minus 1.2, which leaves us with 5.7. We'll now divide that by the size of the panel, 0.6, which leaves us exactly 9 full panels plus 1 filler. Okay, so now we can go ahead and add up our fillers. We have 1, 2, 3, 4, 5, 6, 7 fillers times 2 is 14 fillers. And then we can add up our full panels. We have 24, 31, 38, 43, 52, 57, 60, 67 times 2 is 134. We have 134 full panels and 14 fillers. For corner sets, 1, 2, 3, 4, 5, 6, 7, 8 sets of corner panels. Okay, that's all she said, or wrapped, or whatever, eh?